Today's episode is sponsored by DCM Tech. Visit them at dcm-tech.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. If you haven't already, like and subscribe to get new episodes delivered to your inbox each week. I'm your host, Lawrence Mobes, editor here at SME Media. Today I am joined by Erik Lawson, General Manager at DCM Tech. DCM Tech designs and builds industrial rotary surface grinders and automotive rebuilding equipment. They have provided long-lasting, application-specific solutions to customers worldwide since 1975, and the use of DCM Tech vertical spindle rotary table surface grinders has consistently brought dollars to their customers' bottom line via process improvement. Erik Lawson leads the team of engineers at DCM Tech and has been involved in qualifying and optimizing grinding processes for hundreds of customers. This process validation includes finding the right combination of feeds and speeds, abrasives, and equipment to reach the most efficient process possible. He has extensive experience grinding with materials including ferrous and non-ferrous metals, glass and optics, ceramics, silicon carbide, and more. As a result of his countless hours of research and testing, he is the factory expert on grinding process optimization at DCM Tech. So welcome to the show. Our topic today is rotary surface grinding and 3D build plates in additive manufacturing. So let's get right into it. Erik, first off, can you tell us about DCM Tech and explain how rotary surface grinders are positioned within the additive manufacturing industry?
Yeah, Lawrence, thanks for that introduction. I feel like an expert just from that. As you mentioned, we've been here at DCM, we've been building machines this is our 50th year in business, so it's been a bit of a long haul. And initially it was all focused around automotive aftermarket, but as that industry has kind of fallen away and diminished, the focus went into industrial surface grinding. But our very first product 50 years ago was a flywheel grinder, which was a very basic rotary surface grinder. But if you look at that, as compared to its current machine, which even a fully featured 482, which is a much more sophisticated version, the basic operating principles are the same. So we continue to build that original flywheel grinder similar to what we did back 50 years ago, but then today we also have several versions, both larger and smaller, from a 10 horse all the way to a 50 horsepower spindle motor, and we can go on a rotary table size from as small as 18 inches up to 48 inches. So when it comes to additive specifically, though, our machines are used in the recovery process when the part is, after a part's been printed and front off the plate, that plate needs to be flat and have the right surface finish on it again, and that's what we can provide.
Very good. That makes good sense for sure. How does DCM Tech's expertise in rotary surface grinding and 3D build plates help companies optimize their production processes? What can you tell me about the specifics of that?
Well, we've seen customers demanding different twists on their build plate finish, whether it's a very specific flatness or a very specific surface finish, or sometimes they want both. Oftentimes they want both. But sometimes there is such a thing as being too smooth, and obviously there's a thing as being too rough. All of these things are variables in the process that we have control over. And given that we can tune every parameter of that machine, it gives us the ability to dial that process in for the particular customer and the product that they're building. The optimization part of it comes in time savings, whereas we don't have to grind really, really slowly for that initial material removal. We can come in hard and get the excess part off quickly. And then as the surface area increases, we could do a different recipe or a recipe adjustment, or even use different stages of one particular grind to handle that full surface area versus that basically a minimal area of printed material that has to come off. So we've done numerous attempts at this stuff and had a lot of head scratching on the front end, but we've tried to take good notes and record these things as things work and don't work. In both cases, we can learn either way. But as a result, we have a pretty extensive library of recipes, and there's a high likelihood we'd have one that will work, at least to get you going down a path with whatever you are printing today.
Well, you just mentioned surface finish, of course, and the speed of grinding and some other factors. But let's talk about the key challenges that company face in 3D printing and the 3D printing and build plate space. How does DCM Tech address the challenges that companies face?
Yeah, the original build plates that we saw, we struggled a bit with, and it really comes down to finding a perfect match between the machine recipe, the abrasive used, and what you're trying to grind. And with the sophistication of the printed materials and the way that technology has been exploding, as well as the base metal of plate being sometimes different, and sometimes that's not the same part. Like, for example, if they're printing an Inconel material on an Inconel plate, at least all of the materials being taken off are Inconel. But sometimes they're printing Inconel on a titanium plate or printing titanium on a stainless plate or whatever. But whatever they're choosing to use for their process, that grinder has to be able to manage and handle all of the different combinations as it gets through that material. And the way we can do that is having full control and adjustability of our spindle speed, table speed, and feed rates. That allows us to train that probably process engineer or maybe operator at the site to be able to adjust and work with that machine and ultimately control their machine to handle whatever comes at them. We're not, as a rule, trying to be experts in that particular process. We don't want to own your process. We want to teach you how to use your machine to better utilize it and make the most of it. And then the way the interface is structured, we can save anything along the way and name it. And that recipe then can be used and recalled next time that part comes along, and then easily copied and changed and adjusted for different material quantities or whatever to ease that process development time in the future. But once you have a baseline, you can often get to the next level pretty quickly. The other thing that happens or that can come from this is the abrasive itself. We have a pretty good library of materials on hand, but we do sometimes find the limits of that. But with the adjustments that we have available, such as spindle speed, we can try different things. And what we learn and what we develop will really help shortcut the process of new abrasive development. So if you can call your abrasive guy and tell him, well, it works okay at 1,000, it works really good at 750, but I really don't think it seems to work at all at 1,500. Those are excellent clues for the abrasive guy to develop the next iteration of wheel or segment or whatever you're choosing to cut with. With having that data and telling him exactly what the removal rates are and being able to track those things as well as load of the machine, those are all super helpful. And maybe by the second or at least the third iteration of a wheel, you can get something that works. With the people we've been working with, we found that that's been pretty successful. We do have one particular supplier that has our machine in-house, so that really helps because he actually can test before it even goes out. The other surface finish is the other wild part in that. Sometimes they want it smoother, sometimes they want it rougher. A lot of that can be determined by the time spent when you're at the end of the grinding process. We call it dwell time. So that is, again, another tunable feature, and we can wildly affect that finish on the plate by how long we sit there once it's done. But you don't want to waste too much time there because you're wasting time if it's too smooth, as well as dulling your abrasive for the next operation, so it doesn't do you any good after a certain point. So having control over all of those different aspects really can save you a lot of time and money at the end of the day.
Now, you also mentioned, using data to improve the processes to make it just right. And there's probably, lots of better and less effective ways to approach any challenge. But can you walk us through some of the unique features and innovations that DCM Tech offers in the build plate solutions that set you apart from other players in the market?
Yeah, one of our main recent developments is that our 82 series of machines, so that would be our 282, 382, and 482 sizes. Those machines are all robot ready right from DCM. What that means is there's a discrete I/O cable connection right at the front of the electrical box, and that allows you to interface with a robotic arm, such that if you wanted to have a robot tending that machine, it's an easy path forward, and we're not dedicated to a particular software or company for that robot. It's being discrete I/O, it makes it work with just about anybody. That same line of thinking, an automatic door opener is also available. That's not standard on the machine, and it can be done by a robot if your end effector is appropriate. But the other method is to just use the signal at that connector that'll open and shut the door. The next thing on the list here is we do provide a very rapid changeover for different abrasives. So if you need to finish the plate off with a different sort of abrasive because of the contrasting materials, that's only a couple minutes to change a wheel. It's one single bolt in the center, and it's really quick on the 282. And then we have multiple grind modes as well. The machine can be set to grind to a given dimension if you know where you want to go exactly for print, or we can grind off with a given amount if you know how much you want to take off. We can also use automatic part detect so that we can take off a given amount from the point at which it touches the part. And then finally, we have pulse grinding, which is a different way to attack a part where you're impacting the grind or impacting the wheel into the part, kind of like aggressively hacking at it, which really, really helps with the really hard materials that are otherwise difficult to grind. This is a newer feature that we're just getting out to customers.
Yeah, that's great. I particularly caught my ear when you talked about the robots. That's something I'm always interested in, just personally. But you talked about, the robot usage and integration, the rapid changeover, the, different grinding modes, the auto part detection, and, a few other things that you talk about. Any interesting customer success stories with any of the innovations that you guys offer, or with any of the differentiators that make you guys different from your competitors? Any customer success stories that come to mind?
Well, there's a few that the most recent one, I guess, was the pulse grinding that we came up with late last year. That was in particular was developed really for one particular customer that was struggling with some scale on a part, but we found that it's pretty useful in other applications as well. And it's a very, very tunable feature again, a very powerful feature. And obviously with that comes some responsibility. You have to be careful with what you're doing, because you could do some damage with it as well. But it does get us through some pretty tough spots. And that guy, last I checked on him, he's quite happy with how the machine was running. It was a big win.
Very good. Sounds like a big win for the customer as well. That's good to hear. Now, for customers, users that want to scale up their production, scale up their additive manufacturing capabilities, what role does DCM tech play in enabling industries to scale their additive manufacturing capabilities while still maintaining the required precision and efficiency?
All of our IG series of grinders all have the same interface on them. The HMI is all laid out similarly. But that models I'm talking about start as low as the 180 all the way up to the 482. But if you can run a 180 efficiently, you can run a 482 just walking up to it. You wouldn't need any additional training. You wouldn't need any additional operator sign-offs, any of that stuff. That makes it very easy to add machines to the line if you want to have additional pieces in your model. You could also start small and then add larger machines as you grow, and you're not having to redocument everything and relearn everything. Even the recipes can be moved from machine to machine. You can use a flash drive to do that. If you're dramatically changing, like from a 180 to a 480, you probably want to change some of those speeds. But that could be an easy operation done on Excel. It's just a CSV file, so you can dump it into Excel, make your modifications, save it out again as the 482, and then you're not going to have to reprogram everything that goes in the new machine. And even that reprogramming is not very difficult, but it's really nice to have that baseline to start with. Just to save some time and get started on a new project.
Very good. And it sounds like you're in kind of providing some good services and keeping us in good shape for the present state of additive manufacturing. But let's look forward a little bit. How do you see the future of additive manufacturing? How do you see that industry evolving? And how is DCM Tech preparing to meet the challenges and the opportunities that are on the horizon?
I've been around manufacturing for going on 30 years now, I guess. But I remember when 3D printers came out and they were a really cool toy, and you often used them to make keychains or coasters or something like that. And it was intriguing, but it was slow, and it was really a toy is how I saw it. I guess I almost categorize myself as an old guy engineer now. But today, seeing how those machines are used, now we're making exotic engine parts and brake rotors and rocket nozzles and, very sophisticated pieces, very high value pieces. Parts are getting more and more complex and more sophisticated. And therefore, the base material that they're using, print these on, is also gaining complexity and value on top of that. But what we've seen is some huge innovation in design of parts that has some wild potential in the marketplace. But in order to get those parts to be consistent and perfect, they have to have a solid, flat, precise build plate to build on. And what we can do is provide that consistency and repeatability with a reliable grinder that you can count on to run every day. Additionally, we work with abrasive suppliers. As I mentioned, sometimes we have to get a different wheel created, and we have partners that we work with and like to work with. But we have continued to develop new abrasives for different applications or different blends or different demands based on that customer need. And we just work with them to try to get that ironed out before it even leaves our factory so that we know you have a workable solution when it gets in your door. As far as actual growth goes, as larger printers are getting put into service, people are looking at larger and larger grinders. That used to be our 282, the 24-inch table is a solid machine for all these guys. Today, there's more of them being quoted in the 382 space, which is a 36-inch machine, the 30 horsepower. And then we still have the 48-inch machine with 50 horsepower above that. So those are all, as far as physical growth sizes and part volume sizes. That's the other thing. You can load as many parts onto that table as you want. If you have multiple build plates that you want back to the same dimension, you can fill the table up and do half a dozen refinements. That's what you want to be. And then the other piece of it, post-processing may be an opportunity to utilize grinder as well. If you can hang on to that part, if you need to create a precise flat surface on a finished part, we can do that with the same grinder.
It's funny you mentioned the people thinking of the 3D printer as kind of a toy. Years ago, I worked with an engineer who got a hold of a fairly inexpensive 3D printer and purchased it exactly for that purpose, for a toy for him and his son to kind of play around, experiment with. But they've definitely come a long ways, and the finishing capabilities that DCM adds to the equation can take them to a whole nother level. Any last things that you'd like to add that we haven't covered so far, that you haven't gotten a chance to mention that you'd really like to?
Yes, the last piece of the puzzle is that we're going to be at the Rapid TCD show in Detroit coming up soon here. We'll be at booth 3327, and we're going to have our machine in-house. It's a 282 Series 2, which is our fully loaded 24-inch platform machine with a 20 horsepower motor on it. And then our technical specialist, Adam, will be there to answer any questions you might have or to show you that machine's capabilities.
Yeah, I definitely look forward to seeing that there. I'll be very interested, and I'll stop by, check that out. But I'd just like to say thank you very much, Mr. Lawson. Thank you for joining us today. You shared a lot of great insights, very informative stuff for me personally, and I expect for our audience as well. We really appreciate you taking the time to talk with us today. And I do have one more last question for you. If our listeners want to learn more about DCM Tech, where should they go to get more information?
Well, the number one spot would be our DCM Tech website, dcm-tech.com. And then from there, the technical specialists, there are links on that page, on the contact page, to get you to your regional technical specialist. We only have 3 of them, so they're not very hard to track down. But we just have the country split in 3 pieces, and we get a very personalized level of service from DCM.
dcm-tech.com. All right, well, thank you very much for that. If you'd like to learn more about DCM Tech, you can go to that website that was just mentioned. And to learn more about the latest manufacturing trends and hear more podcasts, you can subscribe to our podcast feed. And of course, you can visit us at advancedmanufacturing.org. Thank you.